Here, we'll discover the basics of the user interface. First, go to the Layout menu and choose Clear all viewports. You should get a blank Clarisse window only displaying menus and the selection bar. This is a very classic menu in which you can perform most of the tasks, setting preferences, creating objects in your project, editing, managing the layout, accessing tools, and even Clarisse's documentation. If you don't know how to perform a specific task, there are good chances you will find what you look for in these menus. There is often different ways to perform tasks in Clarisse, but usually using the Edit and the Create menu, you can do almost everything. Just below the menu bar is the selection bar. This one is very close to the one you have in a web or file browser. You basically know where you are in the project. You'll discover that Clarisse Project's organization is very close to a file system with hierarchy of folders. And what is currently selected? Here, nothing is selected, and that's why there is an empty space. Like a browser, it has back and forward buttons, a selection history button, and some other things we will see later on. This empty space is a viewport. It can be split into multiple viewports, each one containing a widget. A widget is an element of Clarisse user interface. A widget can be an editor, a viewer, or a mix of the two, basically anything displaying project data, allowing users to interact with it. You can list all available widgets in the window menu. Here you have all the widgets available in Clarisse. Widgets can be extended by third parties using Clarisse SDK. On the top right of the viewport, you have little buttons. They allow you to split the view in 4 or 2, horizontally and vertically. The last one allows you to close the viewport. Now click on the second icon to divide the viewport into 2 horizontal parts. Now click on the menu of the second viewport to display the widget list. Now select Timeline. Drag this sizer down to get more space. Here you can see a little button that allows you to fold the viewport title bar. Now click on the split vertical icon of the first viewport. Then click again, but this time on the split horizontal button. Drag the vertical sizer to leave more space to the top viewport. Set the left viewport to 3D view, the top right to attribute editor, and the bottom left to browser. If we create some objects in the project, new, geometry, polygrid for example, you can see the different widgets in action. Here the 3D view shows the selected objects, and here the attribute editor shows its attributes. And here in the selection bar, you can see the path of the selected object. You can also put widgets in independent windows. Go to the window menu and choose Tools. You can arrange the windows the way you want to have a little toolbox. By default, the UI layout is saved in a project. It's loaded back when you reopen it. You can override this setting by opening the Preference panel. In Project section, simply uncheck Load Preferences and Save Preferences depending on your needs. To conclude this tutorial, you can also access to Layout presets using the Layout Presets menu. The Animation workshop is dedicated to animation, the Shading workshop to shading, and the Render workshop to layout and rendering. Into groups. Groups are used to define visibility and light linking. Before proceeding to this mini tutorial, please load the following project file. Groups Basics. There are 3 ways to create groups: using the browser, using the attribute editor, and drag and dropping items into an attribute referencing a group. Using the browser is definitely the quickest way. Select your items, right-click, and select Group in the pop-up menu. This will create a new group with your selection inside. Here is what's inside our group. The second way is using the attribute editor. First, create a new empty group. Create Group. You could also right-click in the browser, New Group. Once created, it should be selected in the attribute editor. Now, if you look the attribute editor, you will see two attributes, Filter and References. References is the list of items that are included in your group. Filter is the class of items you wish to put in your group. By default, it is set to Scene Item, so you can only put items that inherits from scene items inside. For example, lights, locators, geometries, and combiners. Now, lock the browser, so the attribute editor keeps displaying the group even if the browser selection changes. In the browser, click on Sphere, hold Shift and click on Sphere 3 to multi-select Sphere, Sphere 1, Sphere 2, Sphere 3. Now drag and drop your selection into References attribute in the attribute editor. That's it, your group is now set. The third way is to drag and drop items on attributes referencing groups. Groups can be automatically created if a selection is drag and dropped into an attribute referencing a group. Please load the following project file. Groups Basics 2. Now select the background layer of the image and lock the attribute editor. Look for the attribute Geometries that can be found in the Visibility horizontal tab. Select Sphere and Sphere 1 in the browser and drag and drop them in the Geometries attribute of the attribute editor. By drag and dropping the two spheres, the attribute editor automatically created a new group including Sphere and Sphere 1. This group is called Image Background Geometries and you can find it in the browser. If a group is already referenced, this is the case now, you can still append items in the group by pressing Ctrl and drag and dropping new items. Select Sphere 2, hold Ctrl and drag and drop it to Geometries. Sphere 2 is now added to the group. If you simply drag and drop Sphere 3 without holding Ctrl key, a new group will be created containing only Sphere 3. To see the content of the different groups, just select them, unlock the attribute editor, and you see the references list. Back to our background layer, you can reference different groups at any time. Here is a mini tutorial. First, load this project, Scatterers 2 Start Project. And now change the 3D view to Browse for the context Scene. Apply. You will see many objects scattered on a point array. Select Scatterer and look for the Geometry List attribute. Lock the attribute editor and go to the Assets context in the browser. You'll see a castle object which is already in the Scatterers list and a house object. Drag and drop house in the Scatterers geometry list. In the 3D view, we can now see a mix of castles and houses. Let's say there are too much castles and we would like more houses. To do that, simply add the house a few more times in the geometry list. There is now 6 times more houses than castles in the scatterer. Now let's randomize the position of the buildings. In the scatterers attribute, set the position variance to 1 meter in X and Z axis. Now let's randomize the rotation. Set the rotation variance to 360 in Y-axis. If you want the copies to keep a right angle, you can set the scatterer rotation step attribute to 90 on Y-axis. Now we want to control the density of our houses. Zoom out the 3D view to see the whole scene. Select the point array object and refresh the attribute editor. Now it's locked to the point array. Look for the decimate value and play with the settings from 0 to 100%. This attribute controls the density of our points. You can also texture this attribute. Click on the Decimate Texture button and choose the map item. Apply, and now the decimate is controlled by this map. Play the timeline, you'll see our points are animated. If you look at the image gallery, you will see the map here. And this map controls the density of our points. In fact, this animated map is the output of a full Clarisse scene, and you can find this scene in the map context. Let's open a 3D view to display the scene. This 3D scene is actually rendered in real time in our map. This introduces you with the picture-in-picture concept. Basically, any Clarisse image can be dynamically used in any texturable attribute. Here is a mini tutorial covering displacement shaders basics. First, set the layout to Shading Workshop. Replace the image view by a 3D view. Then create a sphere. Create Geometry Sphere. Now create a displacement using Create Displacement. Then assign it to the sphere's shading group by drag and dropping it to the right part of the material linker. The right part of the material linker is dedicated to displacement shaders, while this part is dedicated to materials. Now select the sphere and raise the displacement adaptive span count to 40. In the material editor, add the fractal noise and connect it to the displacement input. Now we have something strange in our 3D view. This is simply because we didn't set up the displacement bounds. Our displacement is basically clipped by the bounding box of the geometry. Now let's fix this. Select the displacement and change the bound to 1, 1 and 1. The result is now much better. If we orbit and look at the back of the sphere, we can see there is a crack there. This is caused by the UV projection seam of the fractal noise, which doesn't tile. In order to fix this, we'll just have to change projection to planar. The crack is now gone. In a material editor, you can play with different nodes and mix them to get interesting results. Like, for example, a cell noise, a blend, connect them to the two inputs. Now connect the blend and play with the mix value to adjust the blend between the two displacements. In this mini tutorial, we will go through material assignment basics. Before proceeding to this mini tutorial, please load the following project file. File open. Material basics. There are several ways to assign materials. First is using drag and drop in the image view. Let's create a new material. In the browser, New Material Standard, and set the diffuse color to 100. Now, drag and drop it directly in the background sphere. The sphere that is selected is the sphere on which we perform the material drag and drop. As you can see, two spheres turned red. The four spheres in the foreground being the combined version of the four spheres that are in the background. Assigning a material to one of its source affects the combiner. There's a second way to assign materials using the material linker. Multi-select sphere, sphere 1, sphere 2 in the browser, or click on them in the image view and hold Ctrl key. Now if you look at the material linker, which is this widget, you can see here this little eye icon, which is the visibility flag of the shading group defined by the geometry. If you uncheck it, you can see the effect of this flag. Here is the name of the shading group defined by the geometry. This number is the number of geometries sharing the same shading group name. This is the name of the material currently referenced by the shading group. To assign a material, you simply drag and drop the material from the browser to the material linker. Now let's see material overriding. Every scene objects, combiners, scatterers, geometries, and even 3D layers share an attribute called material override. This attribute is very useful if you wish to bypass the material that are assigned to geometries shading groups. Now let's create a new material, New Material Standard, and set its diffuse to 0, 1, 0. In the browser, select the combiner. Now scroll down the attribute editor until you see Material Override attribute. Now drag and drop our new material into Material Override, and now the material is assigned. This is a mini tutorial covering light linking. Before proceeding to this mini tutorial, please load the following project. Light linking. Light linking can be set on three different levels: 3D layer level, scene object level, and light level. First, 3D layer level. You can change the lighting of a 3D layer by specifying a group of lights to the lights attribute of a 3D layer. Using the browser, go to Project, Light, Background Layer. In this context, there are two lights, Dome and Distant. Select them, right-click and select Group to create a new group referencing these two lights. Rename the group by pressing F2 to BG Lights. Now drag and drop BG Lights to Project Scene. Now select the background layer in the layer editor and drag and drop BG Lights group into the Lights attribute. Note there are no shadows in the image. This is normal, as shadows attribute of our 3D layer is set to use current context, and no geometries are in the current context. To get our shadows, drag and drop Geometries group into Shadows. Now let's see light linking at the scene object level. You can also override lighting at scene object level. Every scene object has a light attribute where you can specify a group of light. By default, scene objects' lights attribute are set to use layer 3D. This means objects use implicitly lights that are referenced in the layer 3D they are rendered in. Select Sphere 3 and lock the attribute editor. Scroll down to the light attribute. Now using the browser, go to Project, Lights, Sphere 3. Drag and drop Spot into Lights attribute in the Attribute Editor. Unlock the Attribute Editor. Sphere 3 is now only illuminated by the spotlight. In the same way, you can exclude an item from all lights by setting lights to the default empty group located in Project, Default, Empty. Now let's see light linking at the light level. You can also specify which scene objects are seen by the lights by setting Geometry Group attribute. By default, Geometry Group is set to use 3D layer, which means that light sees what's specified in the Layer 3D Shadows attribute. Now go to Project, Geometries, and select Sphere 1, Sphere 2, Sphere 3. Right-click and select Group to group them. Rename the group to Distant Shadows. Select Project, Lights, Background Layer, Distant. In the Attribute Editor, set Geometry Group to Geometries, Distant Shadows. Here, we explicitly set the occluders for the light distant, so Sphere isn't casting shadows from distant, but still receive its illumination from distant and dome. This also applies for global illumination as it's a light too, but instead of using what's set in shadows attribute of the 3D layer, it looks for what is set in the global illumination attribute. Here is a mini tutorial covering image layering. In Clarisse, images are like onions, they have layers. Before proceeding to this mini tutorial, please load the following project file. Layer 3D. Open. In the Layer Editor, right-click on the background layer and select Duplicate. You now have two identical layers. Select Background Copy, press F2, rename it Foreground. Click on the eye icon to toggle foreground layer visibility off and select Background Layer. Now we will set background layer visibility. Lock the Attribute Editor and scroll down until you see the attribute named Geometries. In the browser, go to Geometries context and drag and drop Polygrid into Geometries attribute. Select Foreground Layer in the Layer Editor and toggle its visibility on. Unlock and lock the Attribute Editor to lock its selection to the foreground layer. Again, scroll down until you see the attribute Geometries. Now, in the browser, go to Geometries context and select Sphere, Sphere 1, Sphere 2, and Sphere 3. Drag and drop them into Geometries attribute. As you can see, something goes wrong with the right sphere. In fact, we need to add the polygrid as a black hole to cut out its alpha. So let's see how we can set a matte object to cut out layer alpha. We will now create an instance of the polygrid, localize its matte properties to use it to cut out the alpha for our foreground layer. Select the polygrid and instantiate it using either Ctrl-I or right-click in the browser and select Instantiate. You could also use Edit, Instantiate. Make sure the Attribute Editor is unlocked to display the polygrid instance, which should be named polygrid 1. Now look for the attribute matte object. Here it is. It is displayed in italic as it's a shared attribute. Right-click on matte object attribute and select Localize in the pop-up menu. The attribute name is now displayed in bold. Toggle matte object. Now localize matte alpha and set its value to 0. Now select back the foreground layer, lock the editor, and scroll down to display Geometries attribute. We will now add the polygrid instance to the foreground Geometries group. In the browser, find our polygrid instance, select it, drag and drop it while holding Ctrl into Geometries in the attribute editor. The polygrid 1 instance is added to the geometry group. You can see individual layers by unchecking the eye icon in the layer editor. This tutorial shows you how to use global illumination and ambient occlusion in Clarisse. First, load the following project: GI Occlusion Project. Now let's see how to add an ambient occlusion lighting. This effect simulates a diffuse overcast day lighting. By shading the objects based on how easy it is for lights to access them, corners and enclosed areas will be darker than open ones. In Clarisse, this is handled by a light. Go to the Create menu and choose Light Ambient Occlusion. Our scene is now illuminated by a very soft light surrounding all objects. Now scroll down the attribute editor to see the color attribute. Set it to 0.5, 0.8, and 1. The scene is now lit by a soft blue overcast lighting. This can simulate outdoor sky lighting. You can go further using a texture in the color attribute, and this is explained in the HDR tutorial. For now, delete the ambient occlusion light to revert to the original project. Go to the Create menu and choose in Light GI Monte Carlo. Go to the Sampling tab and set the sampling quality to 14 and max bounces to 2. Now the light realistically bounces from the floor to the other surfaces of the scene. Notice how the blue bleeds on this sphere and the yellow on this one. In the browser, select Self-Illuminated Material and drag and drop it on the left sphere. This is another property of the global illumination. Any self-illuminated surfaces illuminate surrounding objects like in real life. Combined with textures, you can use this to light your scenes with images. This is explained in the HDR tutorial. Because occlusion and global illumination are handled with lights, everything you can do with lights apply to, like exclusion, groups, layering. This tutorial shows you how to use global illumination and ambient occlusion in Clarisse. First, load the following project: GI Occlusion Project. Now let's see how to add an ambient occlusion lighting. This effect simulates a diffuse overcast day lighting. By shading the objects based on how easy it is for lights to access them, corners and enclosed areas will be darker than open ones. In Clarisse, this is handled by a light. Go to the Create menu and choose Light Ambient Occlusion. Our scene is now illuminated by a very soft light surrounding all objects. Now scroll down the attribute editor to see the color attribute. Set it to 0.5, 0.8, and 1. The scene is now lit by a soft blue overcast lighting. This can simulate outdoor sky lighting. You can go further using a texture in the color attribute, and this is explained in the HDR tutorial. For now, delete the ambient occlusion light to revert to the original project. Go to the Create menu and choose in Light GI Monte Carlo. Go to the Sampling tab and set the sampling quality to 14 and max bounces to 2. Now the light realistically bounces from the floor to the other surfaces of the scene. Notice how the blue bleeds on this sphere and the yellow on this one. In the browser, select Self-Illuminated Material and drag and drop it on the left sphere. This is another property of the global illumination. Any self-illuminated surfaces illuminate surrounding objects like in real life. Combined with textures, you can use this to light your scenes with images. This is explained in the HDR tutorial. Because occlusion and global illumination are handled with lights, everything you can do with lights apply to, like exclusion, groups, layering. First, create a new scene, File, New Scene, and use the Layout Render Workshop. Now, create a new sphere and set its radius to 100 meters. In the image view, press F key to fit the sphere. Now create a matte material, New, Material, Matte, and rename it with F2 key, Enviro Matte. Drag and drop it to the sphere, click on the color texture attribute, add a new texture map file, then apply, select the map file and set its projection attribute to parametric. Basically, we will use this map file to texture light, and lights need parametric coordinates. Scroll down in the attribute editor and uncheck linearized and pre-multiplied. We don't need them because the HDR map is already in linear color space. In the map file attributes, set the file name to the provided HDR map. Don't forget to set the file browser filter types to all files to see our HDR file. Open. Now our sphere is textured with our HDR image. Load an object, File Import Geometry, select the object and fit it in the image view. Remove the default light and create a new Light GI Monte Carlo. Now our dragon is now lit by the surrounding HDR texture. As we can see, there's a lot of noise. That's basically due to the high frequency details in our HDR texture. We can reduce a lot of this noise if we go to the map file attribute and set the interpolation mode to MIP mapping. Of course, you can go further, raising the quality of the GI Monte Carlo light. Now create a standard material and drag and drop it on the dragon. Now we can set a little bit of reflection, showing nice highlights on the object. We can enable blurry reflection and lower the reflection glossiness to soften the highlights. You can also use HDR lighting without the cost of Monte Carlo global illumination using the ambient occlusion light. Remove your GI Monte Carlo light and add a new light ambient occlusion. We can't see anything because the ambient occlusion rays are occluded by the surrounding sphere. So select the sphere and uncheck its cast shadows attribute. Now the dragon is lit by the ambient occlusion. Select the ambient occlusion light and look for its color attribute. Drag and drop the map file onto the color attribute to use the HDR to light the dragon. Check sample color texture and raise the quality to 10, and you have the same result as the global illumination, well, without the cost. in Clarisse. First, open this project. You will notice lots of noise and aliasing in this image. We'll discover how to remove it, keeping rendering times to a minimum. In Clarisse, shading, lighting, and anti-aliasing are independent. This is very important to keep your assets independent from shots. In many renderers, the shading quality is multiplied by anti-aliasing quality. The user is then forced to tweak all the shaders to keep render time low if a particular shot needs more anti-aliasing. First, we need to set the material's quality. Select the ray tracer and enable Previs mode. It overrides all the lighting by a very simple one without shadows, allowing us to focus on the shading. We see some noise in the soft reflections of colored materials. Select Reflective Matte 1 and raise the reflection quality attribute until the noise disappears. A value of 10 works well in this case. Now select Reflective Matte 2 and do the same. A quality of 4 is enough for this one. Now we are happy with the shading, we must set the lighting quality. Go back in the ray tracer and disable the Previs mode. We can still see strong noise, but now we know it comes only from lighting. Select GI Monte Carlo and disable Affect Diffuse to temporarily disable global illumination. And now it's easier to tweak direct lighting quality. Select Light. Again, raise the quality until the noise disappears. 14 is just fine. Select GI Monte Carlo again and re-enable Affect Diffuse. Once again, raise the quality until the noise disappears. We still have a lot of jaggies because we didn't set up the geometric anti-aliasing. The good news, it will almost not change the rendering time. Select the ray tracer and set anti-aliasing samples to 4. The render times goes from 23 seconds to 25 seconds. The image is much smoother. You can get a perfect result using 6 samples and a Blackman-Harris filter. Now, if we need motion blur, click on Enable Motion Blur in the ray tracer. You should get almost the same render time. There is a last way to globally refine the quality of your render. In the ray tracer, look for the shading oversampling attribute. If you set it to 100%, it multiplies all the shading rays by the anti-aliasing samples, basically like in most renderers. Intermediate values will multiply a fraction of them. Usually, you should not use this attribute. Try to keep it to 0 and set the appropriate shading quality in materials and lights instead. Now, how to quickly adjust your lighting without waiting for the final quality, and obviously without changing all your settings. You just have to use the quality attribute at the top of the image view. Turn it down to 0, for example, and we will get a very fast, noisy render. In fact, this attribute is the same one you can find in the image object. Here it is. Sampling quality. Basically, the image view shows the sampling quality attribute of the current image. Changing this value allows you to speed up interactivity.